Hi, pre-calculus students. So basically this video is going to be talking about the exploration we were looking at in class about the graphs of tangent and cotangent and looking at a couple of graphing transformations of these functions. So we see a kind of general relationship in these two curves, right? There's the similar shape except this one is increasing for tangent versus decreasing for cotangent. And we kind of have a shift as to where the asymptotes are. So in tangent, we have asymptotes at pi over 2 and 3 pi over 2, versus at cotangent, we have asymptotes starting at 0 and then every pi, right? Another thing to note is just that we can imagine with the graph of tangent that this curve here is continuing down and completing like another same shape that we see here, right? So we could kind of imagine transplanting that. That's going to like complete the shape here. And similarly, we can start to imagine that this is going to keep going up, right? And form another one of these curves, okay? So quickly, we're going to talk about domain and range, and I just want to highlight one kind of feature of thinking about how we can think about one period of tangent. But basically, we talked about this in class, I believe. We have the domain, range, and period for tangent and cotangent, and they have the same range and period, but the domains are slightly different due to where their asymptotes are. So just that the domain of tangent has the asymptote shifted over to pi over 2 for the starting one, versus this one is starting at 0, so there is no kind of first term. All right, so one quick thing to note here is that since the period is pi, we could always find the trend, like if we have some sort of transformation of tangent or cotangent, where there's some, like x gets multiplied by some b value, we can think about the period as being, instead of 2 pi over b, it will just be pi over b here. So we'll say like for transformations, period is going to be pi over b, and this will be true for both tangent and cotangent. There's two different ways you can graph tangent, and I'm going to kind of lay out the map of both ways. So, and really it's two ways to think about one period of tangent. Okay, so one way to think about it is basically the way that we see it on the graph here, which would be like starting at 0 and saying if one period is pi, then I would go from 0 to pi, and we can kind of think about graphing kind of like this half of this curve and half of this curve with x-axis at the start and at the end, okay? So the way I describe that way is you could describe it as like x-intercept to x-intercept. Now, you're going to have to, well, maybe I'll split it like this. So we'll do one little graph here and one little graph here. So the way we'll think about that then, it looks like, I'm going to use a different color. So we know we have an x-intercept at 0, 0, and then I know there's another one pi later, and I know there's this asymptote at pi over 2, and then I can kind of visualize, okay, then the quarter points, this is first quarter and third quarter, and I know I'm going up, so this is 1 and -1. We get our two little kind of curves, okay? So we could graph one period and it would look like that, or we could graph one period from asymptote to asymptote. And so we'll say asymptote to asymptote. And for that, I'm actually going to suggest you center it at the y-axis. So basically what I'm just going to slide up for one sec. What I'm suggesting for that would be like, here is an asymptote, and there's another one symmetric to it on the other side of the y-axis if we extended to the negative side of our x-axis. And then we can think about that curve being centered around the y-axis. And so that would look like we have our coordinate plane. I know there's an asymptote at pi over 2. And I know there's an asymptote at negative pi over 2. I know I'm going to have a y-intercept at my midpoint on the origin. And so then I know -1 and -1 are going to be my other two key points. And I can sketch my curve that way, centered around my y-axis. Okay, so I'm going to show an example where I do a graph both ways, and you can start to decide like which way makes more sense in terms for your own personal methodology. All right, so we're going to flip over to the back of this worksheet and look at some of the graphs. Okay, so the first one is y equals tan of x over 2. And before we do anything else, we want to think about the period. So the period is going to be pi over b, and b is 1/2. So pi over 1/2, which is the same as 2 pi. Okay, so if I'm doing the way where I do x-intercept to x-intercept, I'm going to kind of split this empty space into two sections. So we'll do like way 1 and then way 2. So if I'm thinking about x-intercept to x-intercept, then we'll still kind of plot out like our starting, our first quarter, our midpoint, our third quarter, and our end. I know my way 1 says x-intercept to x-intercept, where we know our first x-intercept's at 0, and then our endpoint would be 1 period later, 2 pi. That means our midpoint is pi. And one thing to kind of keep in mind is because I know this is tangent, then I know, I'm just kind of like already putting this in for myself. I know this is an x-intercept, this is an x-intercept, and this is an asymptote. And then my positives or -1s are going to happen at pi over 2 and 3 pi over 2. So going to sketch a graph then. There's no kind of vertical stretch in this, right? There's no number outside of tangent, so I still am thinking in terms of 1 and -1 for plotting my key points. And then I'm going to mark, say this is 2 pi, and this is pi. Now I'm going to put in I know my x-intercepts at the start and at the end. I know my asymptote down the middle. And now I know I can sketch, I know at pi over 2 it should be, because another thing to kind of keep in mind is I know tangent, as long as there's not a negative sign out front, like they're not a reflection, is going to be at 1, be increasing. So it's going to be at 1 next, and here, again, because it's increasing, it would be at -1 there, and we get that. Okay, so now way 2 says, instead of starting at 0, I'm going to center things around 0, with 0 being my midpoint. In which case, so if we're saying this is 0, then we're saying our end should be half of our period, right? I want half my period on one side of 0, half my period on the other. So I'd say, since I know my period is 2 pi, I'm going to say my end is pi, but my start is -pi. Which puts this at -pi over 2, and this at +pi over 2. Okay? Now, in this visualization, I know then I'm doing asymptote to asymptote, so I have an asymptote at -pi, and I have an asymptote at +pi, and at 0, I have my x-intercept, and these would be my 1s or -1s. Okay, so going into sketch then, I'm going to actually put my y-axis like smack dab in the middle. Say this is pi and -pi. Okay, now it's time for me to plot my points. I know I have that point at 0, 0. I know that then we want 1 and -1, so this is increasing, so that would be 1 versus -1. Now I can sketch my curve. Okay, and don't draw this as a straight line. It really is a curve, so you're kind of curving one way on this side of the x-intercept and curving the other way on the other side of the x-intercept. Okay, so that's just to show you both those ways. You can decide which way you prefer, and we'll definitely be practicing next time we have class. We're going to do one more example, which is this 2 cotan of x over 3. There's only one way to graph cotan, and it's actually easier because we'll always remember there's an asymptote at 0. So then we just go from there. All right, so here, my period, again, I'm doing pi over b, so that's pi over 1/3, and I get 3 pi. That's my period. So I know, again, if I'm doing my start, Q1, mid, Q3, end, that my start should be at 0. My end should be at 3 pi. Divide 3 pi by 2, 3 pi over 2. Divide that by 2, 3 pi over 4. And then the average of these two is going to put me at 9 pi over 4. Okay. So from here, again, now I have to know where the asymptotes happen in cotan versus tan. So I know they happen, it's going to be at the start and the end. So it's always at 0. So this would be asymptote. So it would be asymptote, which means I should have my x-intercept in the middle. And then these would be my like plus or minus 1s. And in this case, actually, because I have a vertical stretch, instead of 1 and -1, it's going to be at 2 and -2. So now I'm going to sketch my graph. So mark 3 pi, 3 pi over 2, 3 pi over 4, 9 pi over 4, and then I'm putting +2 and -2 on here. Now I gotta put in my asymptote at my y-axis. You're just gonna have to do it a little darker. Figure line, an asymptote at 3 pi, 0 smack dab in the middle. And now I need to visualize what cotangent looks like. It's decreasing, so I should start with a +2 here and a -2 here, and then connect the curve. Okay, so what I'd like you guys to do is try out this last one, and we'll practice some horizontal shifts and vertical shifts next time we have class.